So here we're going to talk about integration by parts. Again, if you need help with test questions, area and volumes, come back to school. Integration by parts is one of the technique that you have to be able to do. Basically, it will help you to take integration between like different type of functions, right? So like say you have different type of function, you have natural log, right? You got inverse functions, you got algebra function, you got trig function, you got e to the x. So you got basically 5 different situations that it can happen to you. If a mix of 2 situations, that's a part that you had to think about with using integration by parts. Now, integration by parts, the formula is going to be like this. Integration of u dv is equal to uv minus integration of v du.
Is that v du or u du?
V du. So u times v integration minus integration of v du. Okay. So the trick is this. I'm going to show you 2 tricks. One is called a DI method, which is we're going to show on Wednesday. One is just start by introduce integration by parts and when to using them. So the trick is this acronym L-I-A-T-E, LIATE. L stands for natural log. I stand for inverse functions. Inverse. A stand for algebraic. T stand for trig. E stand for e to the x. You want to set u equal to that in that particular order. Usually will get your problem solved.
T stands for what? E to the T?
T stands for trig.
Oh.
So sine of x, cosine of x, tangent of x, and cotangent of x.
Oh, E does.
So we have a first thing is this case, which is x e to the x. Now, if I want to take an integration to x e to the x, now if you should see this is algebra, right? This is algebra, and this is e to the x, right?
We want algebra first.
You want to algebra first, so you want to do u is equal to what?
X.
U equal to x. Now, what is du? Just dx. Does that make sense? U equal to x. Du is dx. Now, I'm going to have dv. dv equal to e to the x dx, because equal to the rest of the part, because u is a priority. The algebra before exponential, that's the way it is. So dv is equal to e to the x. Now what we can do is we can take integral of dv, right? So v is equal to what? What's integral of e to the x dx?
E to the X.
E to the x. So then all we gotta do is follow the arrangement. Okay, so integration of x e to the x dx is equal to what? uv, which is x e to the x, minus integration e to the x dx.
Who the hell came up with this?
It's a reverse product rule. X e to the x minus e to the x plus c.
See, that's terrifying.
Why?
Because that was mildly complicated, and it was only the first problem. No, more than what it usually normally
It's
first
just a
problem.
lot of moving parts, it's just a lot.
Exactly, but what I'm saying is the first problem's always easy, and then he's gonna throw a curveball at us in like 5 minutes.
Well,
it's gonna be really hard when he has trig.
Exactly.
That is true. I'm scared of Trey.
Well, there are some harder problem, but the one thing that you will probably see on AP exam, they usually give out not as a difficult problem. They usually give something that you can handle, something that you should be able to do. Okay, so how about this? You try this one. X squared natural log of x dx.
John, let's see if this equals 3.
So there was an algebra and there was a natural log.
See, this one already has an extra part.
Yeah. Yeah. But this is not a question you should be complaining. This is a question you should be fine. If you're done, check with each other before you move on.
Dude, the question is, where the hell?
Yeah, it's you.
I just need to simplify this part.
Yeah. Okay, fine. So yeah, I have bus turns to this. On the trig, we have that. So that I just don't have to.
What is, this is not me, this is me. And then this is the other one down.
I don't know if that's right. I don't know if that's right. Hold on. I mean, I got the same thing, but I don't think that's very good.
Oh, I messed up. I messed up. I mean, I couldn't figure out.
Wait, so, wait, you're in? Yeah, I messed up. Let me know when you're done.
What's SC? Oh, no. I'm stupid.
honest, it
Wait,
seems a little
Connor.
redundant.
Connor,
I don't know when
I'm
you
not
do
wrong
it.
for reading that 1 over 3 actually, because when I multiply this, it's x to the
We'll ask him. You're asking me an algebra question, that's not a good idea.
I'm pretty sure I'm right about it.
Oh, okay.
You can't bring an x out of an integration. Yeah, what? You definitely can't do that.
I can bring 3 out though, and then the x's cancel out. Duh. What am I talking about?
I'm gonna give you answers first, and I'll show you the work. So the answer is gonna be x3 over 3 natural log of x minus xq over 9 plus c. Did anybody got it?
Okay, I got the first part. Right?
Oh,
Oh,
no,
yeah,
no,
that's
no,
exactly,
yeah,
that's
yeah,
exactly what I
yeah,
have.
exactly,
That's
exactly.
exactly what I have, yeah.
Amen.
I just didn't.
Yes?
Yes. I just didn't distribute the 1/3.
Because move out to 1/3, and then it's x squared, and then x cubed over 3 times 1/3 equals
X
plus
cubed over 9.
There we go. Oh my god.
It's not that bad, is it?
No, it really isn't. It's okay.
So u is equal to what in this case?
LNX.
Ln of x, and du is equal to 1 over x, and dv is what?
1 over x dx, right?
dv is what?
So we were on the right side.
X squared dx.
X squared, and what's a v?
X cubed over.
So that's equal to uv, which is x cubed over 3.
Yeah.
X cubed over 3, right?
I mean, of course,
And then what?
Oh,
Ln of x minus integration of the v du times 1 over x. So that's equal to x cubed over 3 natural log of x minus integration of x squared over 3, which is equal to x cubed over 3 natural log of x minus x3 over 9 plus c. Does this make sense?
Yes.
Okay, so you want to think about all the time is this. Now I'm going to show you a cool method. It's called a DI method. So DI method is a very simple integration by parts. So D is always in terms of U, right? U is equal to what? U equal to what? Ln of x, right? And what is the derivative of 1 over x, right? And integration of x squared. And that's going to be x cubed over 3. So plus minus. So always like this. Always like this. It can keep on going. Plus, minus, right? It can keep on going. But in this case, you stop right here. And it's much more easier to think about what happened. So you can do this, and it's very, very easy. So here we're going to do one more. What is the integration of x cubed?
what do you mean by plus minus plus minus?
Yeah, what kind of? I'm just reading the plus minus.
Like, what is that?
It just sign is an alternate.
What?
It's a sign. This is called a table method, or called a DI method. Is using table method because sometimes you're going to use in this situation. We're going to talk about this in the sense that you can understand. So, what's the integration of x cubed over 3?
X to 4th over 12.
No, you're gonna. Oh, sorry, you're gonna stop right here. So, here you're gonna just do this. So it'll be x cubed over 3. And minus integration of 1 over x cubed over 3 dx. And you're going to get the same thing. The way it's wording is going to be exactly the same way for DI method.
Wait, you read the ln x?
Yeah, ln of x. Okay, so this case, you're going to rearrange this way. And you're going to say natural log of x times x cubed over 3. And then, so whatever this is, it's going to be pretty interesting because later we're going to actually deal with this in different way. I'm going to show you in a second. So next one, I'm going to ask you to do a same thing, but just integration of natural log of x dx. Now this is the one that we never did before. We're going to come back to the DI method in a second. Integration natural log of x. That's it. There's no other things.
Mr. Can you go back real quick? How did you get like the second half of that equation?
What?
For the table. Like with the table method, how did you get?
Later we're going to come back to it. We're going to come back to it and we're going to show you the format of this. It's going to be much easier. Just give me a second, bear with me. We're going to come back to the same thing, but we're going to come back and talk about the same question. So I just want to do u equal to, we just want to do natural log of x dx. Now this is the one I don't know how to take integrate, right? We know how to take integrate of 1 over x dx. That's natural log of x. But what's integration natural log of x?
What derivative gives you
So again, it's DI method, is a integration by parts, and think about what u has to be.
Natural log of x squared over 2.
How would there, but there's no parts though.
What are the parts?
No,
There's-
there's no natural
We're
log
not
anyway.
using the method that you just taught us, are we?
No, not yet.
Yeah, exactly.
Oh. So what would we use?
It's natural log of x squared over 2.
U is equal to what?
Oh, we're doing use of.
ln of x, good. What is du? 1 over x, good. And what is the dv? 1.
Yeah.
Bro, that's stop.
And v is equal to what? X, good. So be x ln of x, right? Minus integration of v du, which is what? Just 1, right? So it'll be x ln of x minus x plus c. Now, if you pay attention, let's take a derivative of this, right? Let's take a derivative of this. There's a product rule here. So it'll be what? ln of x, right? Let's take a d to the dx of x ln of x minus x plus c. This one's the ln of x plus what? Plus 1 minus 1 is equal to ln of x. So did it go back to ln of x? So we know that this is the integration of this. Integration natural log of x.
Yeah, it made sense except for the fact that I didn't take dv equal 1. But I also
Well, like once you get that
It makes sense? Okay, so I want you to try integration of 0 to 1 arc sine
No, I give up. I quit.
No.
arc sine x dx.
You could even make it sine and do arc sine here.
the sine will be too easy. So you go ahead and try it. And there's also a boundary you have to worry about. So
Neither do I.
Or is it 1 over? Yes. Okay, sure. 1 over. You know what I mean? Is that what's the derivative of arc sine? I feel like that's more cosine.
Is it arc cosine?
Because remember that big side is the 1 or like 1 over, and then that integration was, wasn't it like arc sine 1 over here or something?
Oh, but and we have, it's definite, oh god.
No, but because remember dv is the value there. So du equals x and
Yes.
v
With our time
x squared root 2. You know what I mean?
Why would they want to just
Yeah,
be?
you think v is x?
I feel like you have to be a bad person whoever like came up with this formula. Why would they use u and v? That's only gonna cause
They're
problems.
so
That's
simple.
only
U
gonna
and
cause
V is
mistakes.
way too simple.
Like they could have used that w. Like
I don't know why they do U and B. Oh, I think I know why. Because the product rule is U and B.
Well, whoever did product rule is stupid.
your x is stupid.
And that's probably true.
It's like my
dv equals 1.
right, and then v equals x.
Yeah, I mean, yeah. But like, don't solve because we don't know how to do this.
Hold on.
What's u and v? We gotta use one side of x and that. No, it's x.
No, it's u and v. U is our number.
Well, it doesn't matter. X.
But you put x in front. So
No, I'm putting it behind.
okay, Bobby.
Of course you look
Screw
at
you.
it.
You know, of course you look at it. Yeah, of course you.
There's already like.
So it's just x on
Integration of v.
minus on
Integration of v. Oh, yeah, it would just be x dx 1 over.
X squared.
What are you talking about? It's not x dx. It's x 1 over square root 1 minus x.
Yes, x over the du.
Yeah. What? It's v du.
It's v du. So it's x
du
times
plus
du.
So it's not x dx. Come on.
So it's x over.
Okay.
1 minus
Don't forget the balance. We're doing 0 to 1.
All right. So let's start.
Whoa. Yeah.
We're like inches away.
All right. You need to do the integral on the second part is u substitution. So make sure you got to do u substitution.
Oh, yeah. Yeah, you can do it. It's fine.
Yeah, it's good. Go for it.
You can do it. I forget that we have to do these substitution rules.
Yeah, go ahead. How do you use substitutions? That bullshit.
Yeah, you're so confident, Jonathan.
You said the same thing. Don't even.
My diabetes. You're yelling at me.
No, go ahead. How are you gonna use substitution for that?
What is a du here?
1 over square root of 1 minus x squared.
Good, good.
Yeah.
Okay, dx. So what is a dv? Dv is equal to 1. So what?
V is x.
V is x.
It's x. Good. So then we got uv. Sorry, that's not integration. What is uv in this case?
X arc sine x. X arc sine x. Or arc sine of x. X.
Very, very good. Minus integration of what?
0 to 1.
Pi over 2.
No, we do the 0, 1 after. We just take integration first, and then we can do the between 0 to 1.
X over square root of 1 minus x squared.
dx.
Very, very good. What is it? How do I take an integration of this part?
That's the u substitution time.
That's a u substitution time.
What are we substituting here, Bobby?
Oh, I don't know. He just said this. Yeah.
Okay, so pay attention. You want to do u equal to something, right? U substitution usually you want to u equal to something, and you have a one lesser degree in the question. So therefore, this one is not a arc sine situation because the one lesser degree is a present. It's not integration of 1 over square root 1 minus x squared. It's integration of x over square root 1 minus x squared. So there is a one lesser degree. So one lesser degree means the derivative of that part. So du is equal to what? Negative 2 dx. Does that make sense?
Yes.
Du negative 2 equal to dx?
Wait, isn't it negative 2x?
Negative 2x, yeah, you're right. So then therefore it's going to be x arc sine of x minus integration of square root of u. This is x dx equal to du minus 2x. The x cancel out.
Oh, shit.
So it'll be x arc sine of x minus plus 1/2 of integration u to the negative half du. So it'll be x arc sine of x plus 1/2. What is u to the negative 1/2? It's going to be u to the 1/2 times 2, right?
Yeah.
So they will cancel out.
Whoa, why do you get the plus 1/2 out in front?
Because, because it's a negative integral, and then once you bring the negative, 1 over negative 2 out, it becomes positive.
Oh, that's big facts.
And the u is equal to, u is equal to what? 1 minus x squared, right? And now we're going to do between 1 and 0.
You gotta do the u-bounds, don't you?
No, I'm going to do it in terms of x bound in this case because there was too many things going on. So I'm just going to do it in terms of the x.
Why do you have both the power and the root?
Yeah, that's just confusing.
You're right.
Why do you have the what?
You have square root and also to the power of 1/2.
Well, that'd be like the
Really?
Damn, Bobby.
Okay, so now I'm going to do is I'm going to plug in 1. What happened if I plug in 1? What's the arc sine of 1?
Oh yeah, pi over 2.
Pi over 2, good. And if I plug in 1 in the second part, it's going to be, so it's pi over 2, right?
Yeah.
If I plug in 1 on the second part, it's going to give you 0. Now, what happens if I plug in 0 into the x arc sine of x? That's just going to be 0. And if I plug in 0 in again, it's going to be 1. So it's going to be pi over 2 minus 1.
Oh my god, we're genius.
How did you know that was pi over 2?
Arc sine of
Why
1
are you
is pi over 2.
applying
How do you-
why are you applying the values to both of them
What about-
With arc signing.
if you took the integral
What
of
if
just the last part?
Sine is one way.
Because the whole thing, right? This whole thing is
Wait, so why
the integral of this. So therefore, I just do, because you cannot do integrate and integrate here. So whatever the result is, you just plug in the boundaries.
So then inverse sine, which is arc sine is inverse sine of 1 is the opposite. Negative pi.
Bro, no. Wait, don't think it's the opposite. Think of it as reversed.
Okay, so if I flip the one around.
No, it's like saying if I'm here, Bobby's there, but if Bobby's there, I'm here.
Okay, so like here, you're saying like.
It's like, what's it called, what's that multiplication? Right?
No, it's okay.
All right. Okay, let's go back. The first question was pretty easy. The second question was easy with UV, right? And we're going to talk about why DI method is going to be a very, very cool way to do something, especially something is you have to repeat it, use it. So, shh, guys. Okay, so this one, we're going to come back to talk about a DI method, which is is also known as the cyclic method, or table method. So it's going to be x squared natural log of x dx. So in this case, yeah, it's fine, doable. Stop right here. Integration natural log of x, not too bad. uv minus v du. Integration v du, fine. Arc sine, fine. Here's a problem that you might have is you have x squared sine of x dx. Now, what is u has to be in this case? U equal to x squared, good. What is du?
2x.
2x dx, right?
Yes.
Good.
You want to solve the rest?
Oh, you want us to do the rest of it?
Yeah.
dv is sine of x.
dv is equal to what?
Sine of x.
dx. What is v?
Negative cosine x?
Negative cosine of x, good. So that's that. So we'll just uv, so it's x squared times cosine of x.
Yeah. Yeah, you put the negative in front. Minus
Minus what?
integration
Integration
of negative
negative cosine of x
Two X.
2x dx.
times 2x dx.
Feels like this is something we should already learn.
So it'd be negative x squared cosine of x squared plus what? Plus cosine of x 2x dx.
Are we learning any new math or just all new techniques?
Wait,
Technique.
How is it cosine x squared?
yeah. What?
I didn't say cosine.
Yeah, you did.
Oh, this I just read it wrong. So it'll be integration of cosine of x times 2x, right?
Yes.
So that means I have to do what? I have to do it again.
Bro, what?
Do it again.
Oh,
Do it again.
this is one.
Do it again.
Okay, so do it again.
Complicated? No way.
Use 2X.
There's no way this is.
So this is a by part again. Right part again. Right again. So
Where do you get the negative?
Huh?
Huh? What are you talking about? Because it's a negative cosine and
It's
it's
negative
minus
cosine,
that, so
and you
it's a
just brought
plus
the negative
now.
outside.
No, but where do you get the negative out? Oh, it's a negative
It's
cosine.
always minus.
Oh, okay.
so
You guys are
this part I already take care of. I just need to do uv again. So u is equal to what?
2x.
2x. du is equal to what? A constant, which is very, very, very good sign. If it's a constant, that means you can stop, right? So which is, we're going to talk about why DI method is actually pretty interesting. So then what is my dv, sorry? Cosine of x dx. And what is v?
Sine x.
Sine of x. Okay, good. So far it's good. So it'd be plus, so uv, so it'd be 2x sine of x minus integration of what?
Sine of x 2dx.
Sine of x and 2, this is dx, good. And we should be able to do integration of sine of x now. What's the integration of sine of x?
Negative cosine?
Negative cosine, so it'd be negative 2 cosine of x. So this is a very annoying, right?
Yes.
Let's check out di. And we're going to do plus, minus, plus. Are we okay here? Okay, why do I do plus minus? U is equal to what? In the first case, what is u in this case? U is equal to x squared, right? And this one's sine of x, right? So I'm going to show you something very, very, very cool. I don't know who come up with this shit. It's pretty amazing. So what's derivative of x squared? 2x. What's derivative of 2x? 2. Do you see where I stop? I stop when it's constant. Done, right? What's the integration of sine of x?
Negative cosine of x.
Negative cosine of x. What's the integration of negative cosine of x? Negative sine of x. And what's integration of negative sine of x?
Cosine of x.
Cosine of x.
But why would we go longer if it's just 3 on the left? Or
You can
do
take it
one-
0, that doesn't matter. Okay, so I'm going to show you that it's actually interesting. It's like this. And just connect all of them.
That's why we went more, John. Because you're.
Oh, so you just always have to go one extra.
So it'd be
Okay.
negative x squared, right? Negative x squared cosine of x, right?
Yes.
Minus, so the second part is minus
Oh,
here.
okay, that's why it's minus.
So minus minus is plus. So it's plus 2x sine of x. And last one is what?
Plus
plus 2 cosine of x. Oh, this is a plus, sorry. This is integration of sine of x is plus. So plus c. Same answer as this one. So you stop at 2.
Wait, so why didn't it work like that for the first example?
So this one, you have to know when to stop. So the only thing that you can do is at here you have to stop because it's going to be ln of x and x cubed over 3. And then it's going to be just integration of this part because if you go and keep on taking derivative, it's not going to go to constant. Right? If you take a derivative, if I keep on taking derivative, it's not going to go constant. I'm just going to stop it.
Okay.
Does that make sense? So DI method doesn't really work very efficient here. It's same. It's not more work. It's same amount of work.
So you just gotta know when to use it.
Yeah. So when you keep on taking derivative, it doesn't go to constant. That means yeah, you don't want to go further. Just integrate at that situation, and you can realize that you can integrate this part very easily. So when you integrate, you're gonna stop like this. If more, you have to take a derivative. If you can get to constant, you can go to constant. Does that make sense? We haven't talked about the most complicated part yet. But how about use DI method for this one?
Can you go back to the other DI method real quick?
A DI method is this one or the other one?
The last one, yeah, that
The
one.
last one.
So we took a derivative of that, we would just get x squared sine of x.
What are you talking about?
The answer.
The answer is negative x squared cosine of x plus 2x sine of x
And
plus
I'm
2
saying
cosine of
if we
x.
took a derivative of that, we would just get x squared sine of x.
Yeah.
Wow.
That's incredible.
I don't even math.
No?
I don't
Which
even
one did you
math.
say to try?
Huh?
Which one did you say to try?
I'm gonna tell you in a second. This one you can try both way. It's integration sine x 4x dx. You can try the DI method this time. Now, this is a way worse if you don't do DI. If you do integration by part, it's gonna be very disgusting. So DI is gonna be much easier. Also make sure you have an alternate signs like this. Put in the front, start with a plus.
Did I see the question? Okay, there it is.
That already kind of looks disgusting. It's not gonna work.
Just like the actual one.
Is that what you say when you go to the morning?
Yeah, got it. Even the answer, yeah.
Bobby, you're so ugly, even your parents didn't show up here for.
Ow. I was like, it's kind of big.
You know, it's like your face. Oh, got him.
Oh.
And in case you didn't understand, that was towards the top of Bobby's face.
Can't even see Bobby's face, he has to cover it so, but. I'm smiling here.
No. It has to be in the
No, it's okay. That's Bobby's mark.
Damn. What is it? Damn.
You can call that bitch, you can call that bitch.
Like it's like negative
said it's all
sign,
good.
number one, negative sign.
Wait, Connor, we're not being done, right? This is, I have to do this, right?
I don't know yet.
My God, Connor.
Bobby's stalling, she doesn't have to do words.
No, I'm Bobby. What?
How do you even, oh, no, don't worry.
Huh? This just doesn't seem like it's right. He's not saying this is not just 64. Right?
I think you would.
Yeah, you would.
See?
Okay, so he, okay.
Do you keep the, do you keep it, like, what'd you get for the first integration?
Negative cosine 4x over 4.
Over 4.
Yes, because he's changing it.
So the answer is going to be negative 1 over 4.
Oh, good, no, I don't wanna get it.
X squared cosine of 4x plus 1 over 8x sine of 4x. And then plus 1 over 32 cosine of 4x plus c.
I was getting that though, so I was right. That might not be right. I was right. That's what I asked at the beginning of class. Connor,
Why are there, dude, why is, Mr. Ye, why is that your calc AB class? Like,
Like, who is
no,
the
look, I sat in his calc AB class, there's a kid